Welcome back to the last part of this video right now, and this is regarding to those login credentials. I mean, we have already figured out that things like Dinesh and check might not be stored in this mobile application because they are being used on the online side. Therefore, we do not have access to them. But nevertheless, I have often encountered some service accounts, operator accounts, which has some hard-coded credentials in an application, and they can be also used to interact with the web API or to manage certain things on this application over here. Okay, but before we going hunting for them, let's have a look into the shared preferences file and the encrypted credentials we have already seen in some code snippets over here. Because even if this is not a finding, you will encounter this quite often, and it's nice to have a general approach on how to deal with things like this. And so therefore, let's have a look. Okay, so let's open this application. And we are logged in with the user check and the password hacked at $123, I guess. Okay, so we have seen these information might be stored in the shared preferences, and we can get access to those shared preferences if we're having root privileges. So if we're getting root privileges, we can see the device is not rooted, so this rooting detection is really not that good. Okay, that's good for us as an attacker. So let's see. Those shared preferences are stored in a protected directory, so the sandbox directory. We have talked about this in the application structure. So within data, com, Android, insecure bank. Let's see. Yes, here we have a lot of stuff. Databases. Let's see, do we have additional databases? No, I guess that's the only one which we have already seen in the content provider path. But now we're having this shared preferences. Shared prefs. Oh, we are still in the wrong, I'm still in the wrong directory. There we have it, shared prefs. Okay, let's clear this and then let's have a look. So now we've got my shared preferences, we've got insecure bank reference shared preferences, and we've got this web view Chromium Pref XML. So if we go back into this one, we have seen our first interaction with those shared preferences in the logging activity. And here we can see it's the file my shared preferences. This one is being used over here in this string. And this string, let's search for this one. No, it's not being used. Let's see. Okay, so this one is not being used, which is interesting. At least not here. And here we can see, here we're having my shared preferences. Is it the same string? Yes. Okay, maybe it's just a decompilation mistake that this string is normally being replaced with this variable, or the original code maybe really does not have a reference this string underneath, because they are identical. Yes, these are identical. Okay, maybe a decompilation error. Okay, but here we can see we are having this shared preferences file, and then we are getting those encrypted username and super secure password out of this file, which means this file should contain these two strings, encrypted username and super secure password, right? Absolutely. Let's see. My shared preferences XML. And there we go. Super secure password and encrypted username. And we can see there's a little bit of a mix up over here and also over here. But here we have now those values. We can see those equal sign at the end, and that's a good identifier to be base64 encoded. So we will encounter base64 encoding quite a lot during this course, and I will also keep explaining it more than once. The reason for this is you can skip certain videos, and then it's good to have those information. Okay, now's the question, how can we decrypt this password, this one over here? Because we want to have the plaintext value behind this, even if this wouldn't be in finding because it's within a secure environment and you need root privileges to read this out. So that's not a big deal. But let's say we want to understand how this is being decrypted, because then we can encrypt our own password and insert it over here, and we can simply override the login process with our password. So this would be also pretty nice. Okay, to do so we have to figure out what encryption is being used. So we have to go down the rabbit hole. So let's see, this password is being used over here. So it's being stored in password. Okay, then we've got if the password is not equal null, that's good. Then we are now in this part. Here we have the username. It's not encrypted. It's just base64 encoded. And the password appears over here, but that's not the password variable. The password is only being used in this field over here, in this line. Okay, and here we can see we are setting the text to crypto class, AES decrypt string, and then the password. So it seems like we're having an AES decrypted string function over here. But we do not know this. The developer can choose whatever he likes. We have to figure out if it's really AES decryption. Okay, so let's dive into this one. AES is a very common encryption algorithm, and I will provide you a bonus video where I go through all these important things you need to know about AES. So in case if you're not familiar with AES, have a look into this bonus video and then you might want to come back to this one over here. Alrighty? Okay, back to this one. So let's see if it's really AES. We are using this decrypted string function, so we have to take a look into this one. Okay, so here we are calling AES 256 decrypt. We are having an initialization vector maybe, we're having some keys and our base64 decoded string. Let's see where this function is. This function is over here. Okay, so now let's see. Yes, now we can be sure that we are definitely using an AES crypto function. Why? Because here we can see we are using Cypher get instance AES. And we can see the Cypher is not an own Cypher class. The Cypher is being used from JavaX crypto Cypher. So that's the generic Cypher class from the Android system over here. This means we are using the method get instance, and if you are providing this parameter, we are using AES in Cypher blockchaining mode with padding. Okay, so now we know we are using AES CBC, which means we are having a key and we are also having an initialization vector. I will explain this in detail in the bonus video because I do not want to stretch this unnecessarily long right now. Okay, let's have a look where are those keys and where are those initialization vectors. So we are within this decrypt string function, and let's see. We are calling this function and we are providing the following parameters. This initialization vector get bytes, and also this one over here, this key. And then we are providing our, let's see, this is our base64 encoded string. Okay, nice. This means, let's have a look. This AES decrypt function is using initialization vector bytes as the first parameter and key, sorry, let's do not mess those colors up, key as a second parameter, and this is our text bytes as the third parameter. So this is our text, this might be the key, key, and this one over here is our initialization vector. To be 100% sure, we need to track these variables because the developer can also name them differently to do some obscurity. So security by obscurity. Okay, so here we can see these bytes are being used in algorithm parameter spec, IV spec. So here we can see if we look up this function, this is getting the initialization vector out of these bytes. All right, now we know this is definitely our initialization vector. This part over here. Okay, then let's see, key. Yes, here we are having secret key spec, and this secret key spec is returning the secret key, whoops, wrong color, as a byte array into this one. So this is our key. And last but not least, we've got this text bytes, Cypher do final, yes, that's the parameter where our crypto functionality takes place. So this is our string, our base64 encoded. So this one over here is our string, and this one over here, which has been fetched from the shared preferences. It's being inserted in a byte array, so we are inserting those raw bytes into this function over here. We have now everything together, and the easiest way to do an AES decrypt method right now is simply using CyberChef. CyberChef, it's an amazing tool to perform all this kind of tasks. And there's an online version, but also an offline version if you do not want to decrypt your secrets online, which is something I cannot recommend right now. So we take the offline version. Okay, to get the offline version, we simply have to go to the CyberChef page, and this one over here. And then let's see, we can simply download it over here. So then we are having the web application running on our local system, and we can interact the same, but then we are not giving away those information. All right? Okay, so thanks for having also the opportunity to make this as easy as possible to do this locally. Really thank you, the whole CyberChef crew. Okay, so let's see. Within downloads, we've got now, oh, I've downloaded it twice. We simply extract this directory. That was not good. Oh, I hate when things like this happen. Let's get rid of this one. Okay. CyberChef, let's do it this way. Okay, then let's take it into our tools. Okay, and now let's extract it over here. Yes, of course. Now it's doing it this way. Yes, I know I have hit the wrong button before, but yeah, that's how it goes. All right, now we can simply use or start this HTML file, and the whole stuff is happening in the background via JavaScript. So we can use this offline. That's absolutely no problem. All right, so now let's do this, because that's pretty amazing how fast this goes. The first thing we need to do is we need to get those shared preferences string, the base64 encoded string, this one over here, but without this %. Okay, yes, that's the password. Okay, now we're having the input as an base64 string defined. The first thing we want to do, we want to decode it, because then we are having the raw bytes, and we can use those blocks on the left to simply drag and drop this in. So we say this one here is our input, and here we have now the output. And by dropping in the block from base64, we can see it's now being decoded. So that's the representation of this string over here. That's the base64 decoded string. And here we can see we have those dots where we do not know the real value behind this, because this is binary data and cannot be represented in this text form. This is why we have base64 encoded it. But our AES decrypt function works with raw bytes, therefore we need to decode it first. Okay, then we're using AES decrypt. And now we have to take care about a few things. Our input is not hex, our input is now raw. So we are now taking the base64 encoded string, we are decoding it, and we are feeding it into the next block, into this one here. So our input is raw bytes. We have seen this before over here. I also disable the autobake function, because then we are not getting 1000 errors that it could not decode the string with these parameters right now. Okay, now, I mean, if you want to stay to hex, then you could also use, where do we have it? Oh, we have to repeat it real quick. You could also do it in this way, of course. -n, okay. base64-d and then xxd-p. You could also insert those hex values, and then you could switch it to hex. But base64 is way easier. We do not have to convert anything first. All right, now we need to insert the key. The key, we have already seen the key as this one, this IV bytes. This one, this key, this one over here. And we can see this key is being referenced over here. This is the super secret key, okay. So this is our key, 1, 2, 3. Let's insert it here. And now the key is not in hex format, the key is UTF-8. So that's a basic string over here. Now we need to insert the initialization vector. So what's the initialization vector? This one over here. So it's simply just 16 times. Yes, okay. One thing we need to mention, this one is not a string, this is now a byte array. So we should also keep those types in mind. This means, I'm not sure, no, it wouldn't work if we provide those 16 zeros as a string, because a string, 0 in a string is a different value than a 0 in a byte array. Okay, so therefore we apply these as hex values, and this can be also easily done. Here we already have defined it to hex values, and now inserting 1 0 requires 2 zeros in hex. So this is 1 0 in hex. We can also see, maybe enable this real quick, invalid key length. Oh, that's interesting. Why is it invalid? Yes, so there was an error regarding to the key length, but the key length was probably fine. So by inserting one and removing it, we get the update that it's now correct. Maybe because I have disabled the auto bake feature first. Okay, so now we can see invalid length got 1 byte. So here we can also see this one over here, 2 zeros, is simply just 1 byte, so 1 0. And we need to apply 16 of them. So let's copy this. 1, 2, 3, 4, 5, 6. I mean, we can also look at here until it matches and suddenly our text appears. That's all we need to do. Amazing, right? The whole crypto stuff has been already implemented and we simply reuse those functions. In case if we're not having CBC mode, we can also play around with these modes. ECB, for example, doesn't make any difference. CTR might. Yes, and CTR is the counter mode, so this is a complete different algorithms. Amazing. So now we also got this password over here. Okay, cool. This is how we can decrypt AES encrypted shared preferences file in under 2 minutes. The only thing we have to track down are those parameters. But I mean, if they are using those cryptographic functionalities, which every developer does, of course, because you do not have to reinvent those wheels, you can simply take those keywords, cipher init, do final, things like this, secret key spec. What else do we have? Cipher get instance. So if you're looking for those keywords in an application, then you easily identify all those AES encryption, decryption stuff. Alrighty? Okay, perfect. Last but not least, let's have a look, or let's go for a hunt on hard-coded user credentials. So we have to wait until the application has been decompiled over here. Okay, and what I would do right now is I would go down the rabbit hole regarding to all these login functionalities, because if you have a successful login, there need to be this comparison against a hard-coded credential. But we can also do it more easily, for example with user. And here we can see we want to skip everything which is Android support v4. And that's all. Case insensitive. Yes, this is what we want to have. Okay. Oh yes, we can see we've got a lot of pages over here. So yes. This is that's not a good option, but nevertheless we see it over here. Oh, that's interesting. Username, 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 and here we can see username equals dev admin. All right. Encrypted username. So we have to go down all those things. Sometimes they also do not, of course, compare it with things like user or password because they want to hide their tracks. Then I guess the best option is tracking down those logging functionalities because there needs to be in comparison with those credentials and there need to be in decision if these are correct or not. Okay, in this case right now we have identified this dev admin. And here we can see post data. So we are connecting or we are contacting our web server at login and dev login. So we're having 2 logins, also interesting. By the way, this web server is running on this interface, which means if we go on 172.172.0.0 and then port 80, we can see the web server is also running on our local host. So this means if we go back, then we've got do logging the server port /login. Here we can see method is not allowed because we are making a GET request, but we need to have a POST request. So the thing that happens in the background, the mobile application is connecting to this web server over here and performs these tasks, which means this web server is of course publicly available. I mean, this hopefully not, but if you have a real world mobile application, this web server is publicly available. Then you can also, of course, fetch those network traffic and interact directly with the web application without having the mobile app. As already mentioned, we will do this in the man in the middle part. Okay, so let's go back. Now we've gotten another RP point, dev login. This is something we should take a look into. Okay, method also not allowed, so we need to provide post parameter. Let's see what's being sent. This one is HTTP post 2, okay? Do login, and if the username is equals dev admin, for entity, then we perform our login. So there's no password inside here right now. Yes, so I cannot identify any password for this user right now. So can we simply log in with a username devadmin? Let's find this out. So let's open this one over here. Let's reset it. Okay, devadmin. Let's see, I'm not providing any password and nice, we are logged in. So this is a perfect example for hard-coded credentials. The developer might have used it for development and has forgotten to exclude them from the mobile application and also from the web server part. To be honest, I have encountered this 3 or 4 times within my last 8 or 9 years of mobile experience. So this doesn't happen often anymore. It depends on the type of application, I guess. But this is definitely something you should check out. If this works out, I mean, you got the pony under the Christmas tree. You got directly access to some developer functions or things like this. Okay. One last thing I would like to try out right now is if we restart, because this user might be admin. And within the activities, we have seen there was something really strange. And we've got this button, which might be visible depending if we are admin or not. And this is something I would like to try out real quick. So if we hit autofill credentials, yes, the dev admin appears, but there's no create user button. Nevertheless, the create user button has no functionality and it wouldn't work anyway, but I would like to try it out over here. Okay, so that's all for this challenge right now. I mean, there's a ton of other stuff which is included in there and there might be additional vulnerabilities. In case if you have questions to any of them, then please drop a message into the comment section over here and then yeah, I will get through this and answer them. Alrighty? Okay. So this challenge was absolutely perfect to recap everything we have learned so far. And if we recap what we have learned, I mean, this is already amazing, right? We can handle activities, content providers, broadcast receivers. We've got knowledge about cryptography already. We did identify hard-coded credentials and even more. But don't worry, we are not even being close to our final form. So we've got tons of other stuff which we go through during this course over here. There are some 2 really huge chapters, which is Smiley and Frida. Within Smiley, you will become an absolutely Android ninja, and Frida, it's the bad boy on top of it. So if you go through this course together with me, the whole course, then after absorbing this course, you will be definitely within the top 5 of your company regarding to Android application pen testing. I'm pretty sure about this one. Regarding to mobile penetration testing, Smiley is an ability that not many people have out there. So reading and writing Smiley it's not very common. And within the next chapter, you will see what we can do with Smiley. So Smiley gives us unlimited power in hacking mobile applications. Even if there are some really hardcore routing detections, we do not care about them. So with Smiley, we can do whatever we want and there are not many things that can stop us right now. Alrighty? Okay. So therefore, I'm really looking forward to see you in the next chapter because this chapter has been mentioned to reading and writing Smiley. So we will learn Smiley in the next couple of, I guess, 45 videos. Alrighty? I'm looking forward to see you there.